Hello Mayfield, this is Miss McPhee and it is Thursday, May 12th, and this is our homework for our class, Pre-Algebra, periods 1 and 4, that's due tomorrow, Friday, May 13th. The homework is front and back, and this week we've been continuing our work with looking at powers of 10, both with positive and negative exponents, and specifically the end of the week looking at very large numbers that can be written using the power of 10, and very small numbers that can be written with those negative exponents and powers of 10. I did go to the shoebox and I sensed a trend. Can you do the describing the point section? Can you please describe the point on your video? Can you please do the last question on the number line? So that is also talking about the describing the point. So the instructions were on the front. Let's look at that together. This week we described numbers using powers of 10 and using a standard decimal value. For example, the speed of light through ice can be written as a multiple of a power of 10, such as 2 3/10 times 10 to the 8th, which is equivalent, if we wrote it out in standard form, to 230 million meters per second. Use the number line on the back to answer questions about point A and B. All right, and this was one we started looking at yesterday, and then by today we were a little bit more fluid with it. So I have 0 and I have 10 to the 9th, and I have even intervals counting by 10. So what we discovered is really what we're counting by then is we're counting by multiples of 10 to the 8th power, where this is 1 times 10 to the 8th power, and this is 2 times 10 to the 8th power, and this is 3 times 10 to the 8th power, and this is 4 times 10 to the 8th power. This is 5 times 10 to the 8th power, which is going to come into play down here. This is 6 times 10 to the 8th power, and 7 times 10 to the 8th power, and 8 times 10 to the 8th power, and 9 times 10 to the 8th power, and this is 10 times 10 to the 8th power, which we learned way back in lesson 1 of this unit, that when we multiply with the same base, we're adding the exponents. So that's how we now end up at 10 to the 9th power. So question 1, describing point B, which is right here, as a multiple of 10 and then as a value in standard form. And I think you have enough to answer that question now. Then what we've also talked about this week is taking out a small interval and kind of zooming out and looking at it more specifically. So what we have here is 5 times 10 to the 8th, and then over here, 6 times 10 to the 8th. And again, we have those 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 increments. So we're counting by groups of 10. We're counting by tenths. So this would be 5 1/10 times 10 to the 8th, and then 5 2/10 times 10 to the 8th. And then I'm going to ask you to keep moving from there so that you can describe point A as a multiple with a power of 10. So something times 10, and then we know is going to be 10 to the 8th. And then writing that in standard form. And then plot point C somewhere on the graph, and here's the criteria. It has to be greater than point B, which was here, and less than point A. So you get to plot that point, and whatever point you plot, and there are some variations of correct answers, but there is a range that we can accept. And again, write that as a multiple of a power of 10 with your exponent, and then your value in standard form. So I hope that gave you enough information. I think definitely up here, number line should help. Keep going here, counting by your increments of 1/10. Thank you again for your hard work. It was fun to watch you this week kind of make sense of some of these different looking problems and recognizing why it's helpful to write answers in the form of a multiple of a power of 10. I will see you soon. Bye, Mayfield.